I think we cannot hear yourself. Okay, no problem. If you want, you can start, Holly.
Yeah.
Yes, okay. Okay. Thank you.
So this is actually a good introduction to what I want to talk about, because I want to talk about some of the times when we think we're doing everything right, and yet somehow it still goes wrong and we don't get the result we expected. Not necessarily with things like the mute button, but with bigger things like, I'm going to do a cloud native transformation. So this is a BOF session. So I'm really hoping that we can be interactive. So I have some slides and I'll talk through the slides, but please do put your questions in the chat and I'll answer them, and hopefully we can have a bit of a conversation back and forth, because I've got things that I've seen, but I know lots of you as well will have interesting stories about things that have gone right and things that have gone wrong doing cloud native. So I think some of the things that we can talk about today, first of all, what is cloud native? And then I mentioned we can talk about, how does cloud native go wrong? What are some common anti-patterns that I've seen? And then as well, what are some of the things that I think people should be doing, like doing continuous delivery? And then there's some things that are just really hard to get right, and I'm not sure there is a right answer, like governance. How do you do governance in the cloud in such a way that it's not just really oppressive, but you don't end up with the problems that would happen if you just everybody did their own thing? So the title of this session is Cloud Native is about culture, not containers. And I think that, but one of the problems with cloud native, or one of the things that makes it difficult to figure out what cloud native is there's lots of different opinions about what cloud native means. And a good place to start, if you wanted the one true cloud native definition, is the CNCF. And the CNCF say, there's a whole bunch of words here, but the big words here are, they use microservices and containers to make an application which is dynamically orchestrated. So I say cloud native isn't about containers and it's not about microservices, but the CNCF say cloud native is all about microservices and cloud native is all about containers. And really, if you had to choose who was right and who was wrong, the CNCF, their name is the Cloud Native Computing Foundation. They probably know what they're talking about. But at the same time, I kind of think I know what I'm talking about as well. And I see a lot of times where we have a lot of containers, but we don't do the rest of it. And so then cloud native doesn't work the way we hoped it would. And people like Sam Newman have observed this as well. So Sam Newman said that an interesting side effect of the Cloud Native Foundation, who are so associated with Kubernetes, is that he often ends up talking to people who believe that you can't be cloud native without Kubernetes. And you totally can be cloud native without Kubernetes. And as well, you can have lots and lots of Kubernetes and not actually be cloud native. And interestingly, from when I first started giving this talk to now, the CNCF have changed their definition of cloud native. So if you look at their website now, it doesn't actually list what is cloud native on the website. You have to go off and go see this cloud native definition. And if you follow that link, you get to a GitHub. And you know if something's on GitHub, then probably there's been a lot of change. And sure enough, if you look at this, it's got 18 contributors, which is a lot of contributors. And if you look at the history, it sort of goes on and on and on. There's been a lot of commits as well. And some of these commits are things like translations, but some of them are really substantial changes to the wording. And if you look at the original commit into GitHub, that came from a Google document, and there was 11 drafts of that Google document. So they spent a long time trying to figure out what the right definition of cloud native was. And it's the same if you ask a developer what cloud native is, they'll probably have a definition. It might even be a really good definition. But if you ask a different developer, they'll have a different definition. So, you know, one person might say cloud native means born on the cloud. Another one might say it means microservices. Another one might say it means Kubernetes, like the people who are talking to Sam Newman. And someone else might say, actually, it's really about DevOps. A lot of the things that we talk about with cloud native, like being able to get to production quickly, are actually DevOps ideas. Someone else might say cloud native, it's about being modern and nice, and that often when we say an application is cloud native, we just really mean it was developed in 2020 or 2021. I think sometimes as well, we get so used to saying cloud native, we forget it's actually possible to just say cloud. And sometimes, every now and then, if you ask people what is cloud native, someone will say idempotent. And then everyone else will say, what? So idempotent basically means it's rerunnable. So it means that if you hit an application several times, you'll get the same answer each time. So it's like it's stateless. And that's actually really important in the cloud, because if you want something to be horizontally scalable, and if you want it to be able to be spun down and spun back up, then it's got to have that statelessness to it. So with all of these definitions of cloud native, how do we even figure out what we're talking about and if we're talking about the same thing? I think it's useful to sort of step back and ask two things. One is, what problem are we trying to solve? And also, what problem is the cloud trying to solve? And the CNCF do this. So if you look at the CNCF website, the old version used to have this bit that said, we want to be cloud native so we can build great products faster. And, you know, really we have to go back and we have to be thinking about what problem are we trying to solve. And sometimes I think we all get influenced by fashion. And so we think that we have to be cloud native because everyone else is being cloud native. Well, that's not really a great reason. So let's go further back and think, why did we even want to be cloud? And now it's sort of hard to remember what software development was like before the cloud, but there were reasons that we moved to the cloud. So one of the first reasons that we went to the cloud was cost. By running workloads in someone else's data center rather than my own data center, I could make things a lot cheaper. And the reason they were cheaper was because I didn't have to provision the maximum capacity I needed. So for example, for Black Friday, I didn't need to have enough computers available to be able to handle Black Friday, even though it was February, even though it was May. And so really the reason I saved cost in the cloud was because of that elasticity. I could scale workloads down and I could scale workloads up. Another really big benefit of the cloud is speed. And by this, I don't mean things like GPUs, although they're really important as well. I mean that if I can ship my software just by doing a deploy to the cloud, rather than by having to press it onto DVDs and then mail it out to people, I can release a lot more often. I can get things to users much, much faster, which is really good. But of course, we do also see this hardware-related speed in the cloud, that I can do things like if I need to do a whole bunch of machine learning and I need GPUs, I can just rent the GPUs in the cloud rather than having to buy them. If I want to do something on a quantum computer has to be kept at about 0.4 degrees Kelvin, which is colder than the space between the stars. And so you definitely don't want that, you know, in your own data center, in your own house. You want to use that on the cloud. So you can use quantum computers on the cloud. IBM was the first to make quantum computers available on the cloud, but now several companies do that, which is just really cool. So all of that is a great reason to use the cloud. And then the next question is, well, if the cloud gives us speed and elasticity and exotic hardware, why do I need to be cloud native? Well, what a lot of companies found is that when they tried to go to the cloud, there was this idea that the cloud is like electricity. You can just plug in and take advantage of it. But a lot of people found that they got electrocuted. So we got things like the 12 factors, which were really describing how to write your cloud application so you don't get electrocuted. But I think the main thing to remember is that nothing in the 12 factors and nothing in those reasons for cloud says that you have to do microservices. And cloud native, it's just not a synonym for microservices. For a long time, I've been a consultant with the IBM Garage, and we wrote cloud native applications for clients. But a lot of the time, we wouldn't have microservices. We would just have one application because it wasn't big enough to need to be split into microservices. But we were doing cloud native applications. And other times we'd see clients who were doing microservices, but they couldn't actually get these things deployed. And so I think even though it was microservices, it was not cloud native. And really, if cloud native has to be a synonym for anything, it should be a synonym for idempotent. And I find idempotent hard to even say, much less remember what it means. So that definitely needs a synonym. So now that maybe we have a shared understanding of what cloud native is, what are some of the things that can go wrong? Like I mentioned, I'm a consultant with the IBM Garage, and we help businesses get cloud native, write cloud native applications. And these are some of the things that I've seen go wrong. One is the magic morphing meaning. We all think we know what cloud native is, but everybody has a different definition. Another one is closely related. It's the muddy goal. We don't actually know what problem we're trying to solve, so we've got no chance of solving it. Another one is microservices envy. So this happens when we want to do the right thing. We see businesses like Netflix using microservices, and so we use microservices even if they don't actually make sense for our context. Another one is cloud native spaghetti. What sometimes happens when we do use microservices is we think we're decoupled, but we're not decoupled. We're just distributed. So we have our communication going over the network, but this application, it's just a pile of spaghetti, and every time we change one thing, everything else breaks. Another problem I see has to do with continuous integration and continuous deployment. If a customer says to me, we have a CI/CD, I always worry, because CI/CD, it's a verb. It's something you do. It's not something you buy. And so when we have these tools, but we only release every 6 months, we only release, every 3 months, then it's not continuous. Another problem I see has to do with automation. Automation is hard. Automation is expensive. And so what sometimes happens is we put off doing the automation. We say, I'll do the automation later. I'll do the automation someday. But we never actually get round to it. I mentioned at the beginning I wanted to talk about governance. Governance is hard, and what a lot of organizations do is they put so much governance around the cloud that it ends up basically being as inflexible as if it was on-prem. It's so locked down that it's not cloudy anymore. Another problem we see is the reason that governance is there is because if we're not careful, we can just spin up services on the cloud, forget to take them down, and more money just goes into the cloud, and our cloud bill is going up and up and up, and we don't know what the services are. We don't know who's owning them. We don't know if they're needed anymore. And so we just end up with this money pit unless we have governance. So it's hard. And then finally, I meant one of the reasons that figuring out where the money is going is that ops in the cloud is harder, or certainly ops, if you have microservices, is harder because there's so many moving parts that you need to manage them differently, or it's just going to be chaos. So with that was kind of an introduction, and I do have more slides, but I don't want it to be just me talking all the time. So let me turn off the slides for a moment and let's see if there are any questions. I'd love to know how many of you think of yourselves as writing cloud native applications, and how many of you recognize some of these anti-patterns, or if you've got other questions.
So far, no questions, Holly. We are waiting for the questions.
Okay, I'll give it 10 seconds, and if there's no more question, or if there isn't a question yet, I'll carry on with more slides.
Okay, we are waiting for the questions. Yes.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, more slides.
No questions. Yes, you can go.
No questions. Yep, slides will continue until the questions start.
One question, last minute question.
Yeah.
Yes, I'm just going to forward this message to you via chat screen. Can you see the question, Holly? I sent you via chat.
Yeah. Oh yeah, so the question is it all or nothing, or is there an iterative approach to getting to cloud native? That's a really good question. I think the words cloud native make it sound like either you're cloud native or you're not. But I think you're right that actually it is much more of a spectrum. And there's some organizations that are really, really cloud native, and they've got SRE and they're deploying hundreds of times a day, and they're using feature flags and everything to control what goes live, and they've got hundreds of microservices. But I think there's other organizations that are maybe deploying once a day. The applications are intended for the cloud. There's maybe only a few sort of microservices, and I think that's still cloud native, but it's definitely not as extreme as the ones who are deploying hundreds of times a day. But it's still I think, probably doing a good thing. And then I think as well, there's definitely some organizations that do part of it and not other parts of it. And that sometimes works out fine and sometimes causes problems. So as an example, there was a bank that came to IBM, and they had loads and loads of COBOL software. And not surprisingly, newer challenger banks were really taking their business away because they could respond to clients faster. And so this bank, they looked and they said, I've got to get rid of all this COBOL. I need to do microservices. I need to become modern. I need to rewrite everything as microservices. And we said, great, we can help you with that. But then they added, but our release board only meets twice a year. And so at that point, it doesn't matter how many microservices you have. If your release board only meets twice a year, you're going to release all of your microservices in a big lump twice a year. And I think that's kind of a really bad example of being halfway cloud native, where you have some bits that are cloud native, but because the rest of it isn't cloud native, you don't get the benefits of being cloud native. I think there's probably other ways of being half and half that are okay. Like, for example, if you release really often, but you release one big application really often, I think that's probably okay. You might be better off with breaking your application up, but you're still releasing quite regularly, so that's healthy. And I think there's definitely a path to being cloud native as well. So, for example, if I had something that wasn't at all cloud native and I wanted to try and get it to be more cloud native, the first thing I would do is I'd try and do lots of automation, get all my tests automated, get so that I had really high confidence in the quality, and get so that I had an ability to deploy in an automated way as often as I wanted. And then once I had that in place, that would then give me the confidence I needed to then start doing some other things like, doing more frequent deploys, but I would do the automation first. And we've got another question as well, which is another really good question, which is cloud native the same as cloud native DevOps, or is it part of it? I think DevOps is another one of those words that, like, you could ask 10 people what DevOps is, and you'd get 10 different answers, and they're probably all mostly right. So I think of DevOps really as dev and ops working together, rather than having like a separate DevOps team who used to be the ops team until they got renamed to be the DevOps team, and making sure that you have automation in place to allow you to do really frequent deployments. And I think all of that I would say that is also cloud native. So for that, cloud native and cloud native DevOps are the same. I think cloud native maybe has some extra things as well. So things like if you're doing microservices, I think that would count as cloud native, but it probably, most people would say that's not cloud native DevOps. Cool, good questions, keep them coming. Any other questions?
Yes, so far that's all, but you can go. If any, I will forward the messages to you.
Excellent. Cool, so I'll show more slides. So this is a bit more detail about some of the things I talked about already. So one is this magic morphing meaning. So this meaning that depending who we're talking to, it changes. So I mentioned, oops. Yeah, I mentioned that, we've got all these different definitions. And then that means that we might end up with a situation where my boss tells me to go write a cloud native app, and I write something that deploys 10 times a day, and it's completely automated, and all of my testing is automated, and I'm using feature flags to control what function is available. And then my boss says, but I thought you were going to do microservices, and there's no microservices, so I feel really disappointed. So we both did the right thing, but because we didn't agree what cloud native was, someone was unhappy. And this really comes back to, we need to figure out what problem we're trying to solve. And I want to be like Netflix, that's not a problem that we're trying to solve. We need to figure out, do I want to deploy faster? Do I want to save money? Is this maybe actually about hiring? Am I finding that my architecture is so old and so uncool that I can't hire developers, so I need to do some changes just to make it a nicer place to work? But then because of this, we can get these same sort of misunderstandings where my boss tells me I need to go to the cloud, and I get, I get everything onto the cloud, and we're saving a ton of money, but we still only release twice a year. And then my boss is unhappy because they were hoping that we were actually going to get more speed of deployment. So yeah, we just need to know, what problem are we trying to solve? And when we talk to people, often the conversation goes that we say, well, what problem are you trying to solve? And they say, I need more microservices. But microservices are not a goal. You shouldn't modernize to microservices just because. You should go to microservices because they are going to fix something. So microservices are a means, but they're not a goal on their own. So I already mentioned this story that there was the bank and they said, we're going too slowly, we need to get rid of the COBOL, but the release board only meets twice a year. So the microservices were not going to do what they hoped. If they'd said, we're having problems hiring COBOL developers, we're going to go to microservices, that might have been a sensible thing to do. But I think as well, I think we sometimes get this sort of competition thing where we see some companies having hundreds and hundreds and hundreds of microservices, and we think we need to do the same thing. But like, it's not a competition to see how many microservices you can have. You should be focusing on making the application work for your users and making the application work for your business. And the real risk of microservices is that you end up with a distributed monolith. So this is like an ordinary monolith, except it's way worse because you don't get that compile time checking that you would get if all of the code was compiled together. So there you'd find out things like type errors, whereas if it's distributed, you don't have any type information. So there's a whole bunch of dumb errors that you can get if you're not really careful. And another problem that you see with distributed computing is that if everything is running in the same process, if I call a function, it's guaranteed to execute unless my whole application crashes. But if I'm making a call over a network, I have no idea if it's actually going to even be there when I try and call it. And so I have to do a whole bunch of work for the service discovery, and then I have to do a whole bunch of work to actually figure out if it happened, if the call happened. So we've got another question. So the question is, why is it not a best practice to combine cloud applications and local applications like a database together? Yeah, that's an interesting question. It's not something I know too much about. I actually have sometimes written applications like that in the past where I've had sort of a hybrid architecture, and I really wanted to keep my database on-prem for some sort of data residency reasons, and then I had the rest of it in the cloud because I wanted to change it faster. So that you can do that. And so I'd welcome other people who have more experience of things that go wrong when you do that. But in general, the more you can have the different parts of your application co-located so that they can access each other easily, that's going to be better. So if I'm going from the cloud to an on-premise database, I need to do some extra work to make sure that I've got a secure connection, and I need to open ports and firewalls and that kind of thing, which can be a bit of extra effort. And I may find as well that my cloud application wants to change really fast, and my database can't change at all fast. And so then I end up with a bit of a mismatch. So if everything can change at the same time, that's better. But on the other hand, we live in the real world, and you're quite often going to end up with some legacy systems and you need to access them. So it can be a really good pattern to wrap an API around those legacy systems, and then you can have new, shiny, fast changing stuff. And colleagues of mine did that exact thing a few years ago. We wanted to do a savings app for a bank so that you could round up every transaction and then have it, a few cents each time we go into your savings. And it was all these big PL1 mainframes on the back end. And obviously, like we couldn't change those very fast, but we were doing mobile application. We wanted to be deploying many times a day. So we managed to get it so that we were able to change the mainframe every few weeks, and everything else we did in the front end. And that seemed to work okay. And we were able to get the thing to production in about 6 weeks, which was, we thought was pretty good for that kind of environment. I think, okay, so I think we've got no more questions from that. Any other, before I share the slides again, any other questions or comments on microservices and distributed monoliths and that kind of thing?
One more questions, Polly.
Cool.
I just forwarded you.
Oh yeah. These are such good questions. So what about developer experience when working with cloud native services? That is, I don't have this in my presentation, but it's such a good point. I think one of the really big benefits of cloud native that we don't always talk about is that the developer experience should be really good. Because I think as developers, the thing that we most want is probably mostly we want like ice cream and free beer and a pay rise. But once you get past that, like what makes us really happy in our jobs, I think, is that fast feedback. So it's just awful when you write something and you know it's going to be 6 months until it gets deployed. And so you're not going to find out if anybody's using it, if anybody's liking it, if it even works for 6 months. And even like when you're working locally, if you make a change and then in order to run a test cycle, you have to like spin up this big complicated environment and that kind of thing, and you don't actually know if it works for half an hour, that's really frustrating. So it should be that, you know, the more we can make a change, see an effect, make a change, see an effect, make a change, deploy, the happier we are. So in theory, I think developer experience is way better with cloud native. And I think that's one of the reasons that we want to do cloud native, is to just get that that DevOps developer experience where everything just flows and everything is automated and we don't have these tedious tasks. I think in reality, sometimes the developer experience can be worse with cloud native. So I think with Kubernetes at the moment, for example, especially if you're using raw Kubernetes and you haven't got a PaaS on top of it, there's a lot of stuff that you have to learn before you can even deploy your Hello World application. And there's a lot of setup, and some things that were easy become really hard. And that's not so good. And then I think some of the things like debugging can become much harder, because now you're sort of trying to debug this distributed thing, and half your information is over here and half your information is over there. And when you test locally, it works, but then when you deploy, everything falls apart. And so that can actually be worse in the cloud. But I think, like, I have another talk which is called "The Cloud Should Be Fun, and if it's not, you're doing it wrong." Because I think when we see these things that are hard, we need to sort of put our hands up and say, look, I'm more productive if the developer experience is good. So as an industry, you should be working on things like the developer experience for Kubernetes. So, you know, more PaaS, more of that kind of thing. And then also to your employer to say, you put all these barriers to me deploying and you put all this paperwork in place and you think it's making the software quality higher, but actually it's not. It's just slowing things down. So let's automate. If we care about it, automate it. If we don't care about it, get rid of that process, and then hopefully actually we'll be more effective as an organization. Cool. Any other questions?
We are waiting for the questions.
Okay, I'll keep talking while we.
Okay.
Oh, sorry, go on.
Maybe you can
These are good
count down again.
Okay, so distributed monolith, very bad, very common. So I think, but that doesn't mean there's lots of really good reasons to do microservices, but there's probably also cases when you shouldn't do microservices, and just because everybody else is doing them doesn't mean you have to. So like if you have a small team, you don't each need your own thing because there's only a small number of you. So maybe microservices are just adding overhead. If you're not planning to release these things independently, if your organization doesn't have this kind of the testing that you need to have enough confidence to release them independently, or if its approach to risk is I'm not confident unless I do like a really big run up to each release, then microservices won't give much value. Or as well, if your users just don't need changes very often, then you're probably not going to be releasing these things independently. So for example, when I worked on the WebSphere Liberty application server, we made a lot of changes to how we built the software compared to classic WebSphere. And it meant that we were able to release really fast. Like we could have released every day if we wanted to, but we knew that very few people want a new release of their application server every day. And even though one of the things that we changed was that you could upgrade it with confidence, and like it wasn't going to be a big deal to upgrade it. If you're a bank, you don't want to be worrying about upgrading your infrastructure every day. So we released once a quarter because we knew that was kind of the pace that our customers wanted. Another challenge with microservices is about the communication between the services. So I mentioned that when you want to invoke a remote function, you have to find the service. You have to see if it's there. You have to see if it's backed up, or if it's, does it actually have capacity, or has it got 1,600 requests in its queue? And then you have to prove to it that you're allowed to access it. So that's a whole bunch of things. And so often the way to do all that is to have a service mesh. So you might use Istio, for example. And I think sometimes service meshes have a bit of a bad reputation, and people say, wow, a service mesh, that's really complicated. I'm not going to do that. Instead, I'll just write a little bit of code to handle the error handling, and I'll write a little bit of code to handle the security. And then before you know it, actually, you still have a service mesh. It's just that you wrote it, which maybe wasn't what you wanted, because now you have to maintain it. Another reason not to do microservices has to do with the domain model. If the domain model doesn't split nicely, then microservices are going to be a headache. And I've seen quite a few examples of this, which is the cloud native spaghetti. So I was called into a client, and they were trying to do everything cloud native. They had a fairly small team, but they were doing microservices. But the problem they had was every time they changed one microservice, another service broke. And of course, the point of microservices, the dream of microservices, is that when they're supposed to be independent, they're supposed to be decoupled. But just because you're distributed, that doesn't actually mean you're decoupled. And so if you have spaghetti and it's in the cloud, it's still spaghetti. It's just that it's even worse because now it's actually in the cloud and it's firing out meatballs. So when I dug into what was going on with that application, I sort of looked through the code and I saw a lot of code that was just repeated in each microservice. And I said, why, this code seems to be the same as that code over there. Why do we have the same code? And it turns out that there was quite a complicated object model. So there was about 20 classes and there was about 70 fields. So there was like a lot of fields and a lot of classes. And each microservice needed to use this object model. And they didn't want to be coupled. So instead of having a common library that would have introduced a coupling, they copied and pasted the code. But the problem was that was still exactly as coupled, but it was a lot less safe because it meant if one developer spotted a typo or an error in a name or just wanted to make something a bit clearer and they changed the name of a field, every other service that used that field name would break. So it was super, super coupled. And how it's supposed to be with microservices is that you have all of your microservices and each microservice maps really neatly to its own domain. But what had happened in this case was that there was a single domain for all of the services, which meant they had that coupling. So any sort of questions or comments on that and the microservices spaghetti? Anybody had similar experiences? Okay, let's keep going with the slides then. So please do ask questions at any time as well, even when I have the slides up. So I love this story, and I think it really kind of shows why microservices don't guarantee that you're decoupled. This is a NASA project. It was called the Mars Climate Explorer, and this is what it actually looks like. And if you look closely at it, you can see there seems to be like Scotch tape that's holding that silver thing on. And then there's some of the tubes. I'm sure I've seen similar tubes on a tumble dryer, but I assume NASA knew what they were doing and they didn't actually just go out into their garage and steal a whole bunch of equipment from their tumble dryer and their garbage to make this spacecraft. But even though they did build it properly, it had a really sad fate, which is it was supposed to go orbit around Mars. And instead what happened is it went into Mars, which is less good. And when they investigated to figure out what had happened, they discovered that there was two main components. There was a control tower on Earth, and then there was a control unit in the Mars Climate Explorer. And the space part of it used metric units. The ground part of it used imperial units. And the numbers were sort of close enough that nobody spotted the error until all of a sudden they were just wrong enough that the spaceship crashed into Mars. So in this case, you couldn't have had a system that was more distributed. Part of it was on Earth, part of it was on Mars, but because they hadn't really specified the contract, they hadn't really specified the details of the API well enough, and they hadn't tested it well enough, it ended up being a horrible failure. So I would always recommend that if you're doing microservices, learn about consumer-driven contract tests, which will be another piece in the test pyramid between integration tests and unit tests, because they really will avoid problems. So we've got another question now, which is great. So should we apply DDD, which is domain-driven development, in cloud-native application? Is it a good idea? I think in general, absolutely yes. I think you really need to be aware of your domain. I think DDD, it's a tool in the toolbox. So you can get these things right without doing formal DDD, but you probably still are thinking about the domain, and you're thinking about the divisions between the domains, and you're making sure that you are talking to the domain experts. And DDD can give you a good set of tools to formalize how you get that domain knowledge out of the experts, and how you make sure that you're drawing sensible domain boundaries and that you're aware of your domain boundaries. And so each microservice really should be its own bounded context. And if you have a context that goes across multiple microservices, then that's probably a good sign that actually you're going to get problems, and they maybe need to be merged. And of course, these things are never super clear. So if you take that idea of the bounded context to the Mars Explorer, probably they did have the division roughly right, and control of the spaceship from the craft itself compared to control from the ground maybe were different bounded contexts, and it was fair that they were written by different teams. It's just that there was enough overlap between those contexts, even the bounded contexts shouldn't overlap at all, that those teams did need to be talking to each other a lot more than they did. But I'd love to hear other people's experiences of DDD as well. Like, have you tried DDD? Did it solve problems that you wouldn't have been able to solve otherwise? Did it solve problems more efficiently or more reliably than you would have been able to do without DDD? And certainly, I think we talk a lot more about DDD now than we used to, because the cloud has made it more necessary and super relevant.
Yes, if are there any comments or definition, I could open the microphone. Please raise your hands, my friends. Also, we have another question.
Oh, yeah, cool. So the next question is, for microservices, besides increasing the complexity of the code, it will result in increasing the storage and memory as well, right? Probably, yeah. There's going to be an overhead in, well, maybe. So this is where I wish we had a whiteboard. So if you assume that you have the same amount of code, and then you have supporting libraries, application servers, that kind of thing, and you have the same amount of overhead for each microservice as you would have had when everything was together, then for sure microservices are going to increase the memory footprint quite a lot. So you have your application that's 1 megabyte, you divide it into 10, each mini application is 100 kilobytes, but then you also have this same 500 kilobyte, actually that's ridiculously small. Pretend I haven't mentioned those units. A 500 kilobyte layer of JVM and Quarkus or Liberty or whatever you're using as your runtime, then you're going to get way more overhead. The but there is that sometimes what we used to see before we were doing microservices is that I'd have 10 parts of my application and they'd all be using really different programming models. So one would need this library, one would need that library, one would need a third library. And so when I split them out, I didn't have to take the whole runtime for each one. I could just take a portion of the runtime. So I got a savings there. And the other way you may get savings is if there's one part of your application that's really, really hot and you need 10 instances of it because it's getting so much traffic, and the rest of your application actually doesn't get that much traffic at all. If you, in order to scale your application, if you didn't have microservices, you'd be bringing along the 90% of the application that actually didn't need to be scaled with the 10% of the application that did need to be scaled. So that's going to mean that your footprint is way bigger without microservices than it would be with microservices, where you have just the minimum runtime and then just the minimum part of the application, and that's what you scale. And I think as well, we're seeing a lot of changes in our runtime technology to support microservices. So the runtimes are becoming so much lighter than they used to be, which you could get the benefit of that lightness without microservices, but it definitely was a change that microservices triggered. So for example, with WebSphere Liberty, we wrote it to be really lightweight and to start in like 2 seconds and that kind of thing. And the reason we did that was for developer experience. We said developers don't want a laptop application server with a big footprint. They want something that starts fast. But that was just when the cloud was really taking off, and starts fast, small footprint is exactly what you need for the cloud as well. And so Liberty ended up being perfect for the cloud, and it ended up being really good for microservices. And now we see things like Quarkus that are even more optimized for microservices. So Quarkus is so small and so fast, and a lot of the programming models that we used to have in the monolith were kind of designed, like things like reflection, were designed to give us a kind of a modularity, and now we get that modularity by distributing the application instead. And so Quarkus says, well, we're not really going to support reflection, or at least, we're going to make compromises to how we support reflection on some of these older programming models because we're microservices. And so then it ends up being ridiculously small and ridiculously fast. So even if you have your application spread across a whole bunch of things, each running Quarkus, it may actually be smaller than it would be if it was a monolith on a more traditional application server, or on something like Spring or whatever. Any other questions about microservices, footprint, that kind of thing? Okay, cool. How should we differentiate TDD versus DDD in terms of cloud native microservices? Which approach should we follow? So the short answer is both. TDD and DDD, I don't think they're opposed. I think you can do both. I'm a huge advocate of test-driven development. I've been doing it long enough that now I kind of find it quite hard to not do TDD, even if I'm doing throwaway code. And with both TDD and DDD, a lot of people say the main benefit isn't in like the quality of your code exactly, or it's certainly not something like your test coverage. It's about their design tools that allow you to have clean separations and clean boundaries within your code. So a lot of people say TDD, even though test is in the name, it's actually a design tool, because if I write my test first, I have to think about the externals of my code. I have to think about, what does success mean? How do I validate that success in an automated way? And whereas DDD is about finding those requirements within each domain and finding the domain boundaries. Another thing that has a lot of overlap as well is BDD, which is behavior-driven development. And again, BDD and TDD, I think, are probably quite complementary. BDD will be higher level. So I think TDD covers the unit tests and the integration tests and the contract tests. BDD tends to be focused just on specifying things at that highest level, that user-facing level. But that's the most important level to specify things at, which is why BDD can be really useful. Because definitely what nobody wants, and what I've seen a lot of times, is code that has like 95% coverage and the tests are all green and there's so many unit tests and it doesn't work because we actually missed the thing to say, what is this system supposed to do? How do I know if it's working? Any other questions? Oh wow, we're over time. I got too excited talking, and we had lots of great questions. Thank you very much, everybody.
Thank you very much.
Actually.
Thank you, Holly. Thank you so much.
Thanks all. Enjoy the rest of the conference.
Thank you. Bye-bye.